The human brain is a mysterious and fascinating organ. It is the command center of our bodies, responsible for everything we think, feel, and do. And when it comes to understanding the universe around us, our brains rely heavily on our senses, especially sight. But how do we actually see data? The visual cortex, located at the back of our brain, is the first stop for visual information. Like a telescope receiving light from distant stars, the visual cortex captures raw data from our eyes. This data is then relayed to the cerebral cortex, the brain's outer layer, for further processing. Here, the raw data is transformed into meaningful information. Think of the cerebral cortex as a powerful computer. It analyzes the shapes, colors, and patterns transmitted by the visual cortex. It's like deciphering a cosmic message encoded in the light from distant galaxies. This intricate process allows us to recognize objects, perceive depth, and ultimately make sense of the world around us. In the vast expanse of the cosmos, stars cluster together, forming galaxies and constellations. We don't see individual stars scattered randomly across the night sky. Our brains perceive them as grouped objects, patterns against the cosmic backdrop. This innate ability to perceive order in chaos is at the heart of Gestalt psychology. Gestalt psychology, a school of thought that emerged in the early 20th century, emphasizes that the whole is greater than the sum of its parts. Just as astronomers study the patterns of stars to understand the universe, Gestalt psychologists study the principles of perception to understand how our brains organize visual information. These principles are not mere abstract theories. They are fundamental to how we interpret the world, whether we're gazing at the stars or analyzing data on a screen. Understanding these principles can help us create more effective data visualizations that resonate with the natural tendencies of the human brain. Imagine you're back in time, before the invention of telescopes, gazing up at the night sky. You notice groups of stars that seem to belong together. Some are close together, others look alike, and some seem to form lines or curves. These natural groupings illustrate the principles of Gestalt psychology. One fundamental principle is proximity. Just as stars closer together appear to belong to the same constellation, data points closer together are perceived as related. Similarity plays a role too. Stars with similar brightness or color seem grouped, mirroring how data points with similar attributes are visually linked in our minds. Then there's closure. Our brains tend to fill in missing information to perceive complete shapes, much like we connect the dots of constellations, even when some stars are hidden from view. Symmetry also guides our perception, drawing our eyes to balanced and harmonious arrangements, just as symmetrical galaxies captivate astronomers. These are just a few of the principles that govern how we perceive the world around us. Principles that hold the key to unlocking the full potential of data visualization. Imagine a scatterplot depicting the relationship between a star's luminosity and temperature. Each dot represents a star scattered across the cosmic canvas of the graph. Now imagine these stars are not randomly dispersed, but clustered together like celestial families. This is where proximity comes into play. By grouping related data points closer together, we can visually represent clusters and outliers, much like astronomers identify star clusters within a galaxy. This allows viewers to quickly grasp the underlying structure of the data, revealing patterns that might have otherwise remained hidden. Similarly, imagine using different colors or shapes to represent different types of stars on the scatterplot. This application of similarity helps differentiate data points based on their characteristics, just as astronomers classify stars based on their spectral class. This visual encoding makes it easier to spot trends and anomalies within and across different categories. In the realm of data visualization, closure is like connecting the dots to reveal a constellation hidden within a sea of stars. Imagine a line graph depicting stock market fluctuations over time. Instead of displaying a continuous line, we could use a series of strategically placed dots. Our brains, hardwired to seek patterns and complete incomplete figures, would naturally connect these dots, mentally filling in the missing information to perceive the overall trend. This technique can make data visualizations more engaging by inviting viewers to actively participate in the process of discovery. Symmetry, on the other hand, brings a sense of balance and harmony to data visualizations, guiding the viewer's eye and enhancing the aesthetic appeal. Imagine a bar chart comparing the sales figures of two competing products. By presenting the bars symmetrically, we create a visually pleasing and easily digestible representation of the data. Section 6. Continuity, connection, common fate, tracing cosmic paths. Imagine a complex network diagram representing the interconnectedness of galaxies in our universe. Each galaxy is a node, and the lines connecting them represent their gravitational pull on one another. This visualization embodies the principles of continuity, connection, and common fate. Continuity dictates that our eyes tend to follow the smoothest path, perceiving lines as continuing in the same direction. In the network diagram, this means we naturally follow the lines connecting galaxies, tracing the cosmic web of gravity. Connection highlights our tendency to group elements that are visually linked. The lines connecting galaxies in the diagram visually reinforce their relationship, making it easier to understand the structure of the network. Common fate comes into play when elements move together. While galaxies may not seem to be moving, their positions are constantly shifting due to gravitational forces. This shared movement further emphasizes their interconnectedness, highlighting the dynamic nature of the cosmos. Section 7. Good Gestalt, finding harmony in the cosmic dance of data. In the grand cosmic ballet of data visualization, good Gestalt serves as the choreographer, guiding the arrangement and presentation of data to achieve clarity and elegance. It's about striving for visual simplicity and coherence, ensuring the message conveyed is as clear and harmonious as the music of the spheres. Imagine a dashboard displaying various metrics about a space mission. Good Gestalt principles would dictate that related metrics are grouped together, using clear visual hierarchies and minimal distractions. This ensures the viewer can quickly grasp the most important information without being overwhelmed by visual clutter. Good Gestalt is not just about aesthetics, it's about creating visualizations that are both beautiful and informative. It's about presenting data in a way that feels natural and intuitive, resonating with the innate perceptual abilities of the human brain. Section 8. Encoding and decoding, the language of the cosmos. Just as astronomers use telescopes to observe the cosmos and decipher the language of light, data visualization relies on encoding and decoding information. Encoding is the process of translating data into visual elements, while decoding is the reverse process, where viewers interpret those elements to extract meaning. Consider a bar chart representing the chemical composition of different planets. The length of each bar encodes the relative abundance of a particular element. Viewers decode this visual representation by comparing the lengths of the bars, understanding that longer bars indicate higher abundance. Effective data visualization relies on choosing appropriate visual encodings that align with the type of data and the message being conveyed. Just as astronomers use different telescopes and instruments to study different aspects of the universe, data visualization offers a diverse toolkit of charts, graphs, and maps to explore and communicate data effectively. Section 9. The power of context, cosmic illusions and data interpretation. In the vast expanse of space, even the most seasoned astronomers can be fooled by cosmic illusions. Take, for example, the illusion of two stars appearing close together when in reality they're light years apart. This highlights the crucial role of context in visual perception, a principle equally relevant in data visualization. Imagine a line graph showing a steady increase in global temperatures over time. Without proper context, such as the timescale and historical averages, this visualization could be misinterpreted as alarming, even if the rate of increase is within normal fluctuations. Just as astronomers rely on a deep understanding of astrophysics to interpret celestial observations, data visualizations must be presented with appropriate context to avoid misleading viewers. This includes providing clear labels, scales, and annotations, as well as acknowledging limitations and uncertainties in the data. By embracing the principles of Gestalt psychology and understanding the power of context, we can unlock the full potential of data visualization, transforming raw data into compelling narratives that illuminate the hidden patterns and stories within our data-rich universe.